Well, thank you very much for coming to the talk, My Debugging and Performance Toolbox. For those of you that haven't met me before, my name is Waine, and I've worked with PHP for about 5 years, and I am a software engineer at Sainsbury's, one of the sponsors of the conference. We're hiring for all different types of roles at the moment, so if you're interested in any of the stuff I've talked about, either yesterday or today, then make sure you come and see me, and we'll talk about it. Occasionally, I dabble in DevOps, much to the consternation of the people who actually have that role in our organization. And a lot of the stuff that I'm going to talk about today is a little bit DevOpsy in nature. This is the link to the joined in page where you can review the talk afterwards. Give me some positive or some negative feedback. So, when I started making this talk, I was trying to think of a pithy way to sum it up. And what I got to was, what I'm about to show you is a very opinionated view about how to connect a range of different tools together for the purposes of isolating errors quickly in development and also as they appear in staging and production. The other thing to say is that as a contractor, I often come into a new code base every 6 to 9 months. And the tools that I'm wiring together today help me get to the core of issues really quickly in a new code base. And that's why I've put a lot of time into kind of connecting them together. Equally, when I then go to another developer's desk to help them with a problem, I'll reach out for one of these tools and they just aren't there. And I feel a bit like I'm debugging naked or something. So I then have this conversation, which I've put into presentation form. Most of this is a live demo, so there aren't many slides. I'm just going to switch screens in a minute and demonstrate a few of the tools. So if you'll all join me in a moment of silence, of prayer for the demo gods. What am I going to talk about? Some of these tools you may have already used or perhaps authored. The first one is Charles Proxy. It is a HTTP proxy. It sits between you and say in the browser or as an API client, and then the server that you're calling to. It's really useful because it makes a log of all that traffic and then exposes that to you so you can look for patterns in the data that might reveal an error that you have. Maybe a field that you're expecting to be true is false, and this provides you with a quick look at that. The next tool, probably one of the more interesting ones I'm going to talk about, is XDebug. It has a range of different features, but the crown jewels for me is remote debugging, which allows you to put a breakpoint in the code, and then as you execute the code, stop at that breakpoint and see what's going on. So things like variable state and the path the code takes through the path the request takes through the code. It's really, really interesting. So moving away from development and debugging and kind of into the development, staging, and production area is Xhprof. Xhprof is a hierarchical PHP profiler. And you can sum this up as a system which shows you a list of all the function calls that were used to service a request. And it shows you how long you spent in the CPU, how much time each function took, how many times it was called. So really useful information to figure out where the bottlenecks in your system are. And then finally, in the kind of staging and production area, you've got JMeter. So JMeter takes a user journey through your site, but allows you to times the load by X number of users. And as we all know, in development, code will perform one way. In production, with access to bigger data or more users, it performs a very different way. So we really need to figure out a way to simulate that before it goes into production. And that's what JMeter's for. So for testing, I'm using Behat and PHPUnit, but this isn't a testing talk. Really, it's a talk on how to integrate all of the above with those two testing tools. So for the purposes of this talk, I've produced a very simple demo application. It's got 2 endpoints. The first one creates a UUID, which is just a big string, and then stores it in a file. And then the second one lets you get a list of those UUIDs. It's about 5 lines of code in each one of those methods, but it's just enough to demonstrate the debugging and performance profiling tools. And all of the code is here, Love Software /Toolbox demo. at GitHub. So hopefully the screen will be big enough. I've tested it. But if you want to follow along on your own laptop, please go to that address now. So those are all the slides I have. So this is the code base that I'm going to demo today. The first thing to point out is that it's got a vagrant file. So if later on you want to try this at home, check out the repository, do a vagrant up, and at the end of this file is this line here, which will tell it to run a provisioning script. That provisioning script is up in this build directory, and it sets up all the tools that I'm going to talk about today. So it sets up XDebug, it sets up Xhprof, and it also sets up the demo web application so that you can really get into these tools straight away. Okay, so I suppose I best show you the actual code. As I said, this is very simple. It's a Silex application. Silex is a routing framework, and it allows you to map Lambda functions to bits of code. So here you can see that if I was to post to the UUID endpoint, then I would create a UUID string, I'd persist it using a bit of code that I've written, and then in the response, I'd return a JSON encoded version of that UUID. So really simple. And then correspondingly, for the get UUIDs, this will get all the UUIDs that have been created, and then JSON encode them and return them to the client. And that's all the code really that we're going to touch on today. So let's take a look at this in the browser. See what it does. This is the kind of get UUIDs bit. You can see I've been playing with it today. Lots and lots of UUIDs on a string. Okay, so the first thing I want to show you is Charles. So there are a number of tools that you could use to do this. Windows users might use Fiddler. Linux users, there's a version of Charles for you as well. This is small. Okay, let me see. I'm not sure I can zoom it. This is quite a small part. All the other bits, like anything that's in a browser, I can blow up for you. This, I don't think I can. I should have checked that. So if I go back to the browser and I refresh this UUIDs section here, then in the proxy, you get a list of all the requests which have been made as they happen. You can see them coming in. And then in the, for each of them, you can see an overview. Or not, actually. You know what? I'm just going to take 2 seconds just to change the display a little bit. Let's see if that works. Absolutely not, no. Okay, I will talk you through these things. I'll tell you what, you go for that. I will talk about what's on the screen. So you can see a list of requests which are made from the browser to the endpoint that I discussed. And in the bottom window, Charles is gathering and exposing loads of information to you. So things like the request time, the URL that you hit, the response time. It will also show you all the headers that came back from the service and the content itself. So this is useful, but it's not really revolutionary. You can do that in Chrome by popping out the console and having a look. You've probably all done this when you're kind of debugging AJAX requests. What's really useful is if you could integrate this into your testing tool. I reckon that's as close as we'll get. Thank you. If you could integrate this into your testing tool, and if you imagine that you're developing an API, which I often am, and you're writing a client for that, then if we could send all the traffic from the test client through to the API, then we could use this Charles proxy to isolate errors really quickly when something fails in a test suite. So let's tell this to go away, and let's look at how that might be done. So here, this I can zoom in for us. Let's clear it. Here I've got a test suite with Behat, and if I go and show you what that looks like, in the test folder, You basically write features like this in Behat. You have a scenario which describes something you want to achieve, and then you have a number of steps, and those steps are mapped to pieces of PHP code which go off and do things. So here, I'm creating a UUID, which is analogous to making an HTTP request to that service. And then I'm checking that the response should contain a UUID. And this is really good. It kind of covers the business case for this API. And there they are running. Now, the way that I have mapped that textual string saying request is by using a HTTP library, and that HTTP library respects this HTTP proxy environment variable. So Charles is on the host machine listening on 8888. And if I go over there now, kind of wipe all of the information from it, run the tests again, you can see that each one of those web service calls in the test is now available to look at through Charles. Now, before I was saying this really helps with some fault isolation. So if I go back to the index and I look at my get UUIDs, and if I just uncomment this response variable, you can see that I'm overwriting the list of UIDs with just an empty array now. So the test should fail. Like so. No UIDs in the response. So why is that? Well, we can now go into Charles, we can look at the response, look at the JSON that was returned, and we can see that there's an empty array. If we go back to one of the previous successful ones, we can see there's an array full of those UUID strings. So if you can imagine during development, you can have Charles running in the background all the time. You can send all of your test data through it, and you can quickly get an insight into the traffic between client and server. Okay. So that's okay, but if you can't immediately figure out what's going on from the kind of outside looking in, we need to dive into the code. And to do that, we can use XDebug. So XDebug provides this facility for remote debugging, and it's activated using a cookie header. So wouldn't it be great if we could get our proxy, which is already plugged in to the test suite, to drop that header for us and then start a debugging session? So luckily, Charles does that, hopefully in a way that we can see. Yes. So in this kind of rewrite section here, we can set up a rewrite rule. So for all of the requests that come through, append this little XDebug session cookie to them so that when that hits the server, it will start a debugging session for us. So let's go over to my debugger. Go to index.php. Set a breakpoint next to the first line in that function. And then run the tests again. And here you can see that it's broken at that point. So the journey we've been on so far is we've kind of had a look in our HTTP proxy, didn't really find what we want, so we're now going one step deeper and actually line by line debugging the code. Okay, now when you're in that kind of mindset, you can step 1, 2, and then we see the response has been overwritten, so we can fix that bug. But this is all happening while your test suite is actually running. So if we want to kind of do that again, run the tests over and over again until we find the outcome that we want. For me, that provides and then obviously go and fix the bug, like so. For me, that provides a really tight development cycle by powering XDebug from your tests. Now, XDebug does a number of brilliant things. If anybody is used to working with legacy code, you've probably seen code like this. So the fopen command here, if that file doesn't exist, then it causes a notice to appear. And there's nothing you can do to catch that or stop it displaying, really. It just happens. So quite often, people have done this and put an operator in front of it. And this happens in kind of legacy code bases like WordPress, Drupal all the time. It can be really difficult to track that down. So let's take a look at it. So we've got our errors displayed on, and then we're trying to open a non-existing file. So if we go to the kind of XDebug endpoint that I made, like that, then you get this kind of huge error. So let's try and hide that error using the @ operator. Yay, it's gone away. But when you're actually trying to debug a problem which is hidden in a function which has been suppressed like that, you can literally kind of knock around the code base for hours trying to find it. So XDebug allows you to override that. And even if the @ operator is on, the scream setting will insist that that error turns up on the screen and in your logs as well. So really nice way to, when you're debugging legacy code bases, to figure out potential problems. So let's turn both of those off for the moment. I should have purchased some Sublime licensing before this talk. Sorry, Sublime guys. Okay, so by default, the HTML errors flag is turned on in PHP. When it's turned on and XDebug is installed, XDebug will override the vardum and do some nice pretty printing. So this is what a vardum normally looks like. And then if we return to the default settings of HTML errors being on and refresh, this is what a vardum looks like now. Now, something that I say in the office all the time is that friends don't let friends vardump in order to debug. I think it's really terrible practice because occasionally one of those vardumps ends up in production code. Everybody gets really embarrassed. It's much, much better to do remote debugging where possible. But equally, sometimes you have a huge data structure which you want to view on screen. And in that case, I'd recommend doing this. So that's the kind of XDebug aspect to this talk. I'm going to talk about Xhprof now, the hierarchical PHP tool that I mentioned. So if we look at the top of this code base here, I'm including a script which starts Xhprof. And at the bottom, I'm including a script which stops Xhprof. So if I take a look at those scripts, look at the pre one first. I'm requiring some Xhprof library code, and I'm turning on Xhprof for the duration of this request. And then I'm picking a name for the session that this is going to generate that we're going to look after. And then I'm sending that name back as a header. And then after all the code is executed, I'm saving that run for kind of viewing later on. So if we go back to pre, why am I generating the session name before the thing's been saved? Well, the reason for that is if I send it back as a header, I can use chars to then map individual requests to Xhprof runs for analysis later on. This is really useful during development, but it's really useful when you're doing load testing, because what you want to do is pick the kind of 10 requests that failed in that high throughput load test, and then go back and have a look at their Xhprof runs. So let's take a look at, go back to Charles, and we take a look at some of the headers which have been generated in the kind of tests which we've just run. So you can see, the guys in the front row can see, that there is an Xhprof run ID there. So that uniquely identifies a run which was generated by one of our tests, which we can then go and have a look at. So let's do it. So this is all in the kind of Vagrant file and in the README, so you can do this yourself later on. So if I go to /Xhprof and look at the HTML endpoint that it provides, and then I do a search, I can see in this big long list of Xhprof runs that I've generated that this is the one I'm interested in. So if I click through to it and zoom out a little bit, I think. Okay. Then I get to see a wealth of information about a test run which was generated by one of my behavioral tests. So having a look at the information that's available, in the top box, which I just magnify, in the top box you can see wall time, CPU time, memory usage, peak memory usage, and then the number of function calls which went into generating that request. So looking at some of those metrics individually, inclusive wall time is how long it took, including everything. CPU time was how long it spent in the CPU processing. Memory use was the total amount of memory used, and then there's peak memory usage, which is how far it went up to, and then there's number of function calls taken. So they provide you with some nice top-level information about what's going on. Note at this point, in order just to produce that simple example, I seem to have called 2,116 functions. Really bad, and we're going to address that in a minute. And then you see below that a list of all the function calls. So if I sort them by this metric here, exclusive wall time, all of these are clickable, so you can sort the whole run in a number of different ways. Exclusive wall time is the amount of time spent in a function excluding the amount of time spent in any functions that that function calls. So in this case, file exists is right at the top here. So we must be doing a lot of work with the file system. So that seems a little bit odd, and we'll come back to that in a moment. You can also sort things by number of calls made. So loads of string functions, string pos, string, substring, they look a little bit suspicious as well. We're only returning a little bit of data. Why are we calling them all? And these are all questions you can ask yourself because we're seeing this data. So the next thing I'm going to show you, at first glance, looks a little bit mind-boggling, which is the call graph. There it is. So this is a call graph which represents all the different functions which were called in the order that they were called. It's really big at the moment, but let's just zoom in at the top where we should see some things that we expect to see. Auto-loading, that normally happens at the start of a request. And you can see we go down a path of auto-loading here. Pimple offset get, that is part of the Pimple dependency injection container. So we're seeing on this graph things that we would expect to see based on our knowledge of the code base. So if I zoom out a little bit and then zoom in on this big red box, this is file exists. So this is where we're spending all of our time, and it's right at the bottom of a big chain of function calls. So I wonder why that is. Actually, I didn't think to ask this. Does anybody know why that is? Sorry? Class loading, exactly. So this has pulled up the fact that our autoloader is being created in a strange way every single time we make the request. So there's a very easy way to solve that, which is to optimize the autoloader, which I thought was in my class history. Never mind. So PHP composer.bar install, and I think -optimize with a Z. Optimize autoloader. Okay. So it's taking a little bit more time than it normally would, but it's generating an optimized autoloader, which we'll then use again. So what I'm going to show you now is the difference between one Xhprof run and then the next one. And you can think of this as a bit of a thought exercise as to the process of optimizing and then looking for change in each subsequent run. So we've optimized the autoloader. All we have to do to generate more information is run our tests again. So run the tests. Turn this off, excuse the results. Run the test. And then go back to Charles, go to the bottom of the list, and then look at the headers in the response. We've got a unique identifier again in Charles. And then let's go back again, back again, refresh. And here is the run. Click through to it. So already, just in the top level information, there's a kind of marked difference between what we did previously, which is over 2,000 function calls, and what we've got now, which is around 1,400 function calls. So a really quick difference and a quick win. If we view the call graph, I think there's going to be a huge difference. So if you think about the size of the previous one, this one's a lot smaller, and now we're spending a lot of time in a different area of the application. So if I sort by exclusive wall time again, now we're spending a lot of our time in auto-load class map, but significantly less than 79% of the time in file exists. Another thing that you can do is compare one run with another run. So if I go back to this page, this is the ID of the first one that we called. Oh, this one, okay. Yes, you're right. So you have to do a bit of trickery here. You have to go run 1, and then you have to put in the ID, and then you have to do run 2, run2 equals. You have to go back and find the other ID, like so. Paste that in. But after that, you get a comparison between the two runs. So now we can see the second run, which was run with the optimized autoloader, is significantly more performant in terms of actual time, inclusive wall time, the CPU, and the number of function calls. But it doesn't perform as well in memory. So that brings me on to the point that when you're trying to optimize one thing at a time, it's very easy to get lost by kind of optimizing for CPU for 10 minutes and then going for memory. You should take a really rigorous approach. And I've got an article in the README file, this one. I saw a talk by Lorenzo Alberton about Xhprof ages ago. And Lorenzo is a really rigorous person anyway. All of his writing is absolutely brilliant. But he shows you how to get started with Xhprof there. And if you're like me, you're probably thinking pasting IDs into strings in order to do comparisons is a pain. So underneath that, there's an article by Lorna talking about how to start with Xhprof GUI. That's a step up in terms of UI, but it's also more complex to install, so I didn't do it for this demo. And then worth a mention is Sensio have produced a kind of next generation Xhprof-like tool, which apparently has a really good UI. I've not had time to test it personally, but I think it's definitely worth a mention. I think it's called Blackfire.io, so if you're interested, make sure you check it out. So, we've now got a sequence, like a development pipeline, as it were. You are writing behavioral tests or unit tests. You're capable of debugging those both on the you can debug the test, and you can also debug the API call that test generates. All the while, when you're developing those features, you should be thinking about performance. Every time you run those tests, you can harvest the Xhprof run IDs and then do comparisons like one run versus another run. You can do that in development, but you can also do that on kind of live-like, in a live-like environment. It's worth mentioning that Xhprof can be run in production with certain settings disabled. So I think that the CPU flag, which tells you how long you spent at the CPU, apparently that is expensive to run in production. But if you omit that flag, it's okay to have Xhprof running like 1 in every 1,000 requests, and then gathering that data from your live servers and then using it to figure out if there are any bottlenecks in production. But before we get to production, there should be another step, which is simulating production-like load on a known environment and applying all the techniques we've learned so far in order to get some learning as to how the thing is going to perform in prod. So to do that is the kind of next tool in the toolbox, which is JMeter. Now, JMeter gets a really bad rap, and people say that it's really complex, but actually, I think it's fairly simple. I'm so confident that I'm going to try and build a JMeter test plan right now. So the first thing we're going to do is add a thread group. So you can think of a thread group as a way of controlling how many users are going to do the journey that we're about to plan out, how many times that journey is going to occur, and also maybe you want to ramp up the number of users over time, because it's no good saying I want 1,000 users to all visit the site right away, because that's not really how production traffic works. Or it might be, that might be your business. But for me, normally there's a bit of a ramp up in which we might have 50 users, 100, 200, and scaling a test like that enables you to learn where the breakpoint is. So in a thread group, we can do some config. So the request defaults is something that you pretty much always put in. And in the request default, you put the URL of the server that you're going to hit. Like so. That's pretty much the only thing you need to put in. And then you can add a sampler to the thread group. A sampler, in our case, is just a means of making an HTTP request. So let's open this out a little bit. To do that, you need to specify the verb, so get and post, and then the path. So we're looking for UUIDs. We're going to get them. We don't have to fill any of this in because it's taken care of by this request default section. And we'll probably give it a name, like get UUIDs, like so. And then let's put another one in, which to do the post. So sampler, HTTP request, /UUIDs, but this time let's talk about the post, and we'll call it post UUIDs, like so. So the only thing wrong, well, there are two things wrong with this test at the moment. One is that if we set the journey to loop, it would just hammer the server without putting any kind of gap in there. And what we're really trying to simulate is a user journey where we can then multiply that journey by 100 users. So if you think about the journey of a shopping cart, you might create a cart, browse to a product page, look at that product page for 3 seconds, and then add something to your basket. Or it may take you kind of 3 product page lookups before you put something in your cart. So let's put a timer in there. It's a constant timer, and we'll put 300 milliseconds delay in for get UUIDs, and add another timer for the same, like so. So that's going to wait 300 milliseconds. For our case, that's going to be enough. It's just going to throttle it a little bit, so we're not just going to hammer that little test server. For your case, you should do something to figure out what those timings are. Sometimes you can get them from access logs of an existing server. We've also had instances where we have a user who is sitting in front of the UI, interacting with it at kind of their leisure, and then figure out the timings for the request based on that kind of direct user input. It's really important for this to be realistic. And then we need a way of viewing all the results. So there's loads of listeners which you can use. The most useful are view results in a tree, in a table, which will just show you a table of all the requests. And then view results in a tree, which will allow you to inspect an individual request if you want to. And then the summary graph, response time graph. Because management love graphs, so you're going to have to show them something. And then let's just run this once as a test. I won't save it. Okay, so that didn't work. UID. Okay, let's have a look here. Pasted that into the wrong box. Okay, let's try that again. Still did not work. Okay, something's wrong there, but luckily I've got something that I made earlier, Blue Peter style. Okay. Let me fix that. In there? Yeah. Good man. Okay, so now we've got a test which is working. So if we go to this get UUIDs, we can see the result, which importantly contains the Xhprof run ID, because we're going to put those things together in a minute. And if we go to the view results in the table, we can see these failed ones. And then we can also see the successful ones. So let's ramp this up a little bit by going to the thread group and saying, let's run it forever. Just with one user still, but that should just generate us some interesting traffic, like so. So now if I go and kind of pick one of these at random, back to JMeter, view the results in a tree, let's have a look at this one, Xhprof run ID, go back to the UI, refresh, and then look for it, and it's there. So you can imagine that if you were running a load test and you had a lot of these on a lot of different instances, you could ship them somewhere to a common web route. Maybe you dump them all in S3, and then at a later date, you just go through anomalous kind of results from JMeter and pick out the interesting ones, and then perform that analysis on them. So let me just check my list and check that I've covered everything I wanted to say. Oh yeah, there's a few other things that JMeter does. One is to allow you to verify the success of a request based on its content. That is a little bit more complicated, so I'm not going to display it today. But a common technique there would be if you're doing this on your website rather than your API, then look for the footer and the text which should be in the footer. That will show all the that will show that the page at least rendered correctly. And then the other thing that I should say is that JMeter is also producing some interesting metrics, and I'll explain what they are. This one on the right is one of the more important ones, which is latency. So this is the time that it took to return the first byte of that request, whereas the other thing, which is sample time, is the amount that it took to receive the whole request. So I was working at a company a while ago, and we were moving infrastructure from a dedicated environment to a cloud environment, and moving from Apache to Nginx. So we're doing a lot of things new for the first time. And this kind of latency number would be fine up until about 50 users, and then all of a sudden latency would go through the roof. And that came up doing this type of testing, and the reason was that we hadn't configured our Nginx pools correctly. So the HTTP requests were stacking up and waiting for Nginx to deal with them. And that is a classic example of the kind of thing that you find out when you're doing this kind of testing. So, I should also demonstrate the response time graph, display the graph there. So these are the two requests over time. These graphs can be pretty interesting when you've got non-trivial examples. One of the graphs which is particularly interesting is if you've got a login area of your website and you're using bcrypt, you'll notice like an increase in the amount of time that it takes to do that initial login call. And that's normally because you're decrypting something. So that kind of request normally sits up a lot higher than the rest of your requests. And this kind of test design phase is interesting, and it can be informed by user testing, but you can also hook in your user tests, because presumably as a stakeholder you will have defined a journey. So like given I go to the homepage and I create a basket and I put products in the basket, you've defined a bunch of steps that you want your customer to make. So wouldn't it be great if we could feed that into JMeter and somehow it would make a test out of it, and then we could just ramp up the amount of traffic on that journey? Luckily, using HTTP proxies, we can do exactly that. So if I stop this test now, I create a new one. Nope. So this workbench area under here, you can just kind of put samplers and tests in just to test them. One of those is the HTTP test script recorder, which is, for all intensive purposes, is just a proxy that you send traffic to. And then on top of that, you can put a recording controller. So if I go to this HTTPS test script recorder and tell it to start, it asks you to install an SSL certificate, which you do, and then go back to your tests. So previously, the proxy was located on 8888, and that's the address and the port that Charles is using. Now we've got a new proxy, which JMeter is exposing, and that is on 8080, or another port of your choice. Run the tests, which pass, but they also, if we expand this section, put the HTTP requests into this recording controller. Now, if I were to add a thread group, I can then drag and drop these samplers into the thread group. And if I were to run that test now once, oh yeah, I'd also have to add, of course, something to view this listener, view results in a tree, play it. You can see that that's basically mimicked the user journey that was defined in that behavioral test. And then if you imagine that we wanted to test that, we could put some appropriate timings in place, and then we could multiply the number of threads by 1 million and do some kind of load testing with that. So I think that demonstrates that all of these things connected from a development standpoint and all the way through to staging and production, it's a really valuable process to do that and to be constantly aware of not just the story requirements, but also the non-functional requirements as well. And it's really what that toolchain is all about. One last thing to say is that you can do JMeter as a service. So if you don't want to generate the load yourself, you can farm that out to another company, and they will provide the load for you based on your test plans. So I think that's all the demoing that I've got to do today. So I guess, are there any questions in the room about any of this stuff?
Lucky me. Can you just run through the Behat again? So you typed, I mean, I saw you type English, sure. But how that related to actual tests, right?
Yeah, so...
I don't know if I missed it or...
No, I may have done a little bit of kind of a smoke and mirrors game where I didn't show you exactly how that worked, but we've got a little bit of time, so let's dig into that. So in the client that I mentioned, this HTTP client, which is performing requests against the API, that's called Guzzle, which is a fairly popular client. Guzzle has made a service description, or I've made a service description here, which basically lets you map methods to endpoints of your REST API and call them. Now, without any kind of interference, it would just make a direct kind of web request over HTTP. But because Guzzle respects this environment variable, which I'm passing into the PHP script, it will tell Guzzle to use a proxy rather than going directly to the source. And it's at that point you hook in. And you can also, I'm demonstrating this for APIs, but you can also do this for Mink, which is the UI testing bit of Behat. So if you're using Mink to drive a lot of interactions, you can also use a proxy, capture those interactions, and do your UI test journeys as well. This gentleman here.
Hi. I'm curious that you seem to be combining load testing with profiling, because profiling will normally slow down your application significantly. So you're not really load testing, are you?
Well, that's a good question. So apparently, you can run Xhprof in production. I'm providing that you don't run the CPU flags. It's supposed to be a very light kind of touch, whereas something like K-cache grind adds a significant overhead to your requests. your next question is probably, have you measured that overhead or, or similar? And I'm afraid I haven't. This is just an approach that I use, probably without thinking about it enough. The other thing that you can do, actually, is to do, say, 1 in 1,000 requests. So say you're doing 1,000 users, you can use the JMeter data, which will be mostly unprofiled to get the kind of broad themes, and then you could use the Xhprof ID to extract a profiling run while the system is under load. And it's that I'm trying to capture, really. It's what happens when you're using a prod data set and a prod amount of users.
But if you actually did want to load test,
yeah,
you wouldn't do that same thing, I guess.
I guess no. I guess this is something that I'm doing pre-prod in order to get insight. And yeah, I think I would probably turn Xhprof off if we were doing the kind of final load test before prod. That's a good point. Thank you. Gentleman at the back.
Hi.
Hi.
Are there any other load testing applications or services that you recommend?
So I've heard talk of like Apache Bench, which is the classic one, which lets you throw lots of traffic at something. Really, JMeter was just the first tool that I picked up and was able to get working correctly. And also, the kind of JMeter as a service stuff provided by BlazeMeter and the other companies really works for me. So I don't want to figure out how to create a load testing infrastructure. I just want to design it and pass it off to somebody that can generate the load for me. But yeah, there are others. Apache Bench is one.
Thank you.
Are there any questions in the other room? Or? No? Any questions here?
Is it possible to parse the result in JMeter? I mean, consider the first request would be login that generates a random token, and the next request is a logout that uses that token.
Yes, that is possible, and I've really only showed like the bare minimum of functionality JMeter offers today. You can do journeys in which, for example, you harvest a session token from a logon request, and then you use that session token to make subsequent requests. And you can also do that, so say you have 1,000 threads, you can have them do that journey and there will be 1,000 unique tokens created. So you're not kind of trampling on the same session, which might have different performance characteristics than if you had 1,000 separate users on the site. So yeah, really haven't demonstrated the breadth of JMeter. You can do kind of, if this responds like this, then do that. You can do loops. It's a really diverse tool. And actually, I link on the README notes to this talk, this kind of introduction to JMeter video, which is done by BlazeMeter. And there's kind of 5 videos which show you the most basic example, which is probably the one I've done today, versus like an actual customer journey across a site and how to capture all the things involved. Any more questions?
I have one if you want.
You have one?
Just, yeah. If you've mentioned a couple of alternatives to the various components, except for the proxies.
Yeah.
I have a few in mind myself, but do you have any opinions on the alternates?
So I've used Fiddler before. Also worth noting, it's not a proxy, but Wireshark is really good if you need more information lower down than the kind of HTTP layer. You can apply the same kind of approaches that you do with Charles, send traffic to it, do deeper analysis. You have some?
Yeah, sure. You've got WebScarab, which is a Java web app one. And you've also got Behat Proxy, which is great because you can scale the text for presentations.
You've been waiting a long time to say that, haven't you?
And there's a couple others also. The one thing is Charles is also paid, so the other ones are free, so it's just an extra advantage.
Yeah, that is true. I've got lucky enough to have access to a site license, so I haven't had to pay myself. But yeah, that's worth noting. You do have to pay $50 if you want to use it. Any more questions? Okay, thank you very much for coming. I really appreciate it.